In this question, it is given that a runner completes exactly one full lap around a circular track while maintaining constant reading on their speedometer. So, what does this statement mean? That constant reading on a speedometer. So, a speedometer measure speed. So, I can say since reading of speedometer is constant, then speed is constant. But at the same time, that runner is undergoing circular motion, right? So let this be the starting point. So this is the starting point, and it is given that the runner is moving with constant speed. And when he complete exactly one full lap, we have to identify two choices here. They are saying that total displacement of the lap is zero. I think this is correct because if that runner starts from this point, so this is initial point, and after one complete rotation, it reaches exactly at that point. So initial point and final point are same, and displacement is shortest distance between initial point and final point. So since initial and final point are same, I can say displacement is zero. So one option is displacement is zero, of course, for complete or full lap. So this is correct. Then they are saying a runner's average speed is zero. This statement is wrong because that runner has actually traveled this much distance and it would have taken some time. So speed for option B, I am saying speed will be equal to distance upon time. Distance is not zero, distance is not equal to zero, and time is also not equal to zero. So from here I can say speed will not be equal to zero, right? So this is statement that you are saying average runner's speed is zero. So this statement is false. Okay. Now what is third option? That a runner experiences zero acceleration. Now see here, if particle is moving with certain velocity, let that velocity be equal to 2 kilometer per hour. So this particle is moving 2 kilometer in 1 hour. If no force acts on this particle will continue to move with this speed only, 2 kilometer per hour. And this particle cannot change its direction by itself. If this particle change its direction, it implies some external forces acting. So if no external force is acting, particle will continue to move in a straight line. If particle is changing direction, it implies force is acting on particle. So in this case, suppose particle was here. So this should be the direction of motion of particle. After some time, that particle reaches this point and it is moving in this direction. So direction of particle has been changed and it implies some force should be acting on it. So I can say direction of particle is changing. And to change direction, what is required? It implies force should be present and If force is there, then particle should be accelerated. Why? Because force is equal to mass into acceleration. So force is there, it implies acceleration should also be there. So if direction is changing, I can say particle is accelerated. But what they are saying? They are saying that acceleration is zero. So if they are saying that acceleration is zero, then this is incorrect statement because we know that acceleration is not equal to zero. Now, last point. The runner's velocity is continuously changing. Yeah, of course, this is changing because if particle was here, this was direction in which particle was moving, right? Okay, let me draw another diagram. So suppose if particle is here, then this should be direction in which particle is moving, right? So what is velocity at this point? It will be equal to v and direction is j cap. This direction along x-axis is said to be I cap. Along y direction, it is said to be j cap. After some time, moving like this, particle reaches here. So its velocity, of course, its speed is constant, but now it is moving towards minus I direction. If this direction is I cap, this direction will be minus I cap. So this direction is minus I cap. So magnitude of velocity is not changing, but of course, direction is changing. Here particle was moving towards y direction. Here particle is traveling towards minus x direction. So at each and every point, direction of velocity is changing. So if direction of velocity is changing, I can say, yes, this option is correct, which says runner's velocity is continuously changing. It is continuously changing. C, direction is continuously changing. So option D is also correct. So I can say for option D, velocity is changing. But can I say magnitude is constant? Yes, magnitude of velocity. If this is velocity, then its magnitude is constant. But velocity is not constant. Why? Because its direction is changing. Direction is changing. So can I say velocity is changing? Of course, velocity is changing because its direction is changing. So option D is correct. And displacement is zero for one complete rotation. Not rotation, but for one circular motion or circular lap, I can say displacement is zero because initial point and final point are same. So I can say option A and option D are correct. You have to mention all these points while writing FRQ questions. Then only you will be awarded full marks.